Microservices are usually built to be called by applications or to be used by external consumers. The way it's done will determine a lot how the software should be developed and how it can evolve. There are three main ways how you can expose your microservices outside. The first method is to expose all microservices directly. The second one is to build special microservices that are called facades that will represent an entry point into your system. And the third method is to use the external software called API gateways that will provide those external entry points. Let's look into each of those options in detail. The first option is to expose all microservices directly. You simply build a RESTful interface, implement some sort of security, and then you publish those interfaces to outside consumers. If you need to change an interface, then you'll provide backward compatibility at each microservice independently. That's a very simple approach that doesn't require a lot of effort, but it has lots of significant drawbacks. The first one, you will have lots of entry points into your system and it will complicate development of the clients. The second and the most significant one, that it will expose your internal design to the outside world. And if you need to change something, like merging several microservices together or deprecating some of those microservices, you won't be able to do that easily because it will break your consumers. And the third one, it will affect your security because you won't have a perimeter. All your microservices will be exposed directly. So you will need to handle security at each component and basically treat your entire system as non-trusted. That will create a lot of extra complexity because you will need to take care of the security at every component. And also it will introduce additional latency because all the calls must be encrypted and authorized. So this method should never be used in the real microservices systems because of those drawbacks. The second option is to expose your microservices through especially developed facades. There are three different ways how you can do that. The first subtype is to have only a single facade that exposes the entire functionality of the system. This method will allow you to protect your internal designs and make evolution of the microservices a lot easier. You will have only a single entry point into your system. It will make easier for consumers to use your system. The facade will give you a place where you can introduce additional logic, where you can provide some sort of caching or call multiple microservices and compose their results and return as a single object. You can use consistent development practices for your internal microservices and your facades. You can build them, you can version them, you can release them, and you can deploy them into production using the same set of processes and automated templates. This approach is entirely platform agnostic. It will work on any cloud or on-premise deployments. And facades are not limited in functionality. You can do anything what you can do with your regular code. You can convert protocols, you can expose external interface as REST and make internal calls through gRPC or Thrift. You can receive asynchronous messages and then publish notifications through WebSockets or mobile push notification services. So it gives you a lot of flexibility. The drawback of that approach is that you need to do extra work to implement those microservices. And if you need to introduce a new feature into your system, most likely it will affect your facade. So facades will be constantly updated. You should be using microservices when you have a known number of consumers that will be using your system and a relatively small API. The second variation of facades is so-called backend to frontend facade. That facade is built for specific type of consumer, usually an application, and it's optimized for calls, requests from that application. So it has similar pros that the first option. You can protect your internal design and make the future changes a lot easier. You will have only a single entry point for a specific application. You can be using consistent development practices to build your microservices and your facades and release them into production. This approach entirely platform agnostic. You can implement lots of logic inside of facades, optimize your requests, provide some sort of push notifications. And the only con that you can see there, that's additional work that you need to implement. You should be using this approach if you have a few applications that are your consumers and you don't need to worry about any other consumers that could be existing out there in the future. And the third option under facades is implementing multiple facades. Each facade can expose a logically well-defined set of features to your consumers. Similar to single universal facades, they will protect your internal architecture. You can use consistent development practices. It will be platform agnostic. It can work on clouds, on premises. You can implement different logic, use multi-protocol conversions, add asynchronous notifications, optimize client requests. And in addition to the single universal facades, when you're making changes in your system, only a single facade will be changed. So facades that won't be affected by that change will stay untouched. So this approach you can use when you have multiple consumers, or some consumers can be added in the future, and you have a relatively large APIs that makes sense to break it into smaller, well-defined chunks. The third option to expose your microservices is to use third-party technologies. There are different options you can have there. There are cloud-specific implementations of API gateways available on Azure or AWS cloud. You can have free and simple solutions using ConkHQ or NGX+. Or there are complex and feature-rich API management platforms that will not only provide external interfaces but create websites, documentation, client SDKs, and a lot more. There are a number of pros using API gateways. Similar to facades, they will protect your internal design and it will make evolution of your system a lot easier. You will have a single entry point into your system, and API gateways are very good providing cross-cutting concerns like security, logging, throttling, tracing, and others. Cloud-native solutions are already pre-integrated with other cloud-native services like identity management and logging. So you don't need to worry about that. You will get this out of the box. API gateways are implemented by companies that focus on security, and by delegating that security to teams that know how to do that will help you to make your system a lot more secure. And if you use an API management platforms, you'll get a lot of functionality. They will generate external websites for your clients, generate documentation, client SDK, and do a lot more. But there are a number of significant cons. First of all, this is a new technology that needs to be learned and maintained within the organization. And if it's not an issue for you right now, it may become an issue in the future, especially if you're using components from companies that may go out of the business. Some API gateways have a limited functionality, so if you need to do something non-standard, let's say, receive asynchronous messages and publish them as WebSockets or Socket.io notifications, you may be out of luck. And the most significant challenge that to manage large APIs with API gateways, you'll need to introduce a new set of practices to develop those components, version, release them, and deploy them in the production. So the way how you build your microservices and the way you will be dealing with your APIs will be a completely different set of processes, and it will require a different approach. So when it makes sense to use API gateways? First of all, if your API is the product that you're going to sell. So adopting API management platforms that will give you a lot of functionality for free makes a lot of sense. Also, if you're building a cloud-native solutions and decided to integrate with services like identity management and security, those integrations are already done in cloud API gateways for you, so you don't need to worry about that. And another reason why you may use API gateways, if you have a very strict security requirements, so you trust providers who know how to do that, to bring this functionality into your system. Now you may ask, which approach would be the best for you? Unfortunately, there is no silver bullet there, and it will depend a lot on your requirements. But the solution that I found the most universal and works the best in most cases is a combination of a simple API gateway that is used as a simple pass-through layer and implements cross-cutting concerns, together with several facades that will expose functionality of the system outside. This approach has the best combination of pros and cons. It will give you that layer of indirection that will protect your internal architecture and will allow easy evolution. You can use consistent development and delivery practices for your facades similar to your microservices. And you don't need to worry that much about API gateway because more likely it won't change over the course of your development. You can use different protocol transformations, send notifications, optimize your requests on those facades, and when it will come to cross-cutting concerns like security and logging, that can be done at the API gateway level without much effort. When you need to deploy your system on a specific cloud, using cloud-native API gateway will give you out-of-the-box integration with cloud services as identity management and logging without extra effort on your part. And by delegating security to API gateways, you can enhance it and make your system a lot safer. And the only drawback here is extra work that you need to put into implementing those facades and putting API gateway. And I use this approach pretty much anywhere where it makes sense. If you want to learn more about microservices DevOps and industrial software development practices, visit our website at www.ntinco.com and subscribe to our channel. Thank you.